So now that we've spent all this time drawing force diagrams, we're going to learn how to use these force diagrams to solve problems. So we start by drawing the force diagram. We're going to identify all of the forces and identify which are equal in magnitude to each other. And then we're going to recall that Fg equals mass times 10, okay, mg. So for instance, if I have a box hanging from the ceiling, I want to find the force of tension in this cable. So I'm going to start by drawing my force diagram. Okay, so I've got a force of gravity, right? And I've got a equal and opposite normal force. Okay, again, this is on the box by the earth, and this is on the box by the rope. So, I'm sorry, we would have called that a force of tension. Okay, so force of gravity, force of tension, and these are going to be the same as each other in magnitude, right? So if I know the force of gravity, then I know the force of tension. So I'm going to set Fg equal to mg, right? And the mass, we need it in kilograms, times 10 gives us 100 newtons. So the magnitude of the weight is 100 newtons. If you want to be really specific, it's going down, so it's negative 100 newtons. Okay, and since the acceleration here is 0, F net is 0, so the force of tension is going to be 100 newtons. Okay, so negative 100 newtons down, and we got 100 newtons up. So the force of tension in that rope is going to be 100 newtons. What if I'm hanging a bigger box now by 3 separate cables? I want to know the force of tension in each cable. Okay, so I'm going to start by going ahead and drawing my force of gravity. Okay, on the box by the earth. And then I'm going to have 3 separate, you could draw them all kind of next to each other there. They're all going to be a force of tension on the box by the rope or the cable. Okay, so they're all Ft and they're all the same here. Okay, so we might say that 3 times Ft plus the force of gravity equals 0, right? Because the acceleration is 0, so the F net is 0. Well, so 3 times the force of tension plus mg equals 0. So 3 times what we're looking for plus 300 times minus 10 equals 0. 3 times the force of tension, all right, equals 300. So the force of tension in each cable is going to be 100 newtons. Okay? Sound good? So in this example, we have 2 boxes now hanging from the ceiling, so by 2 different cables. Okay, since we have 2 objects, let's see, I'll call this one A and this one B. We're going to need to write 2 force diagrams. Okay, I'm going to start with the bottom one because I think that's a little simpler. It just has a force of gravity, right, here. Okay, so that's on box B by the earth. And then we've got a force of tension, okay, on B by the rope connecting up to A. Okay, and then if I want to do the other one, so A has a force of gravity. I'm going to make that about half as big because it has half the mass. So this is on A by the earth. And we've also got a force of tension, okay, force of tension on A by B. This and this, these are Newton's third law pairs, right? Force of tension of A on B, force of tension of B on A. So those are the same size. And then I'm going to need a force of tension okay? A bigger one here on A from the rope or the cable, okay? And I would say that these are equal in magnitude, and perhaps you can see that this one and this one are equal in magnitude to that single one. So starting with the bottom, okay, we want to know the force of tension in this cable right here. Well, we can say the force of tension plus the force of gravity equals 0, okay? So the force of tension plus mg equals 0. Okay, force of tension plus 10 times minus 10 equals 0. Your force of tension is going to be 100 newtons. Okay, so this is the mass. The weight is negative 100 newtons. The force of tension here is 100 newtons. Okay, so this is 100 newtons tension in that cable. So now for A, the top box, got a little bit more complicated. I have two forces of tension. So I'm going to call this first one force of tension 1 and the second one force of tension 2, so you know what I'm talking about. So the force of tension 1, that's the one that's going upward, plus the force of tension 2, the one going downward, plus the force of gravity should all equal 0, right? Because our net force is 0. So force of tension 1 plus force of tension 2, okay? And we already know what that is, right? So if this is 100 here, this is going to be negative 100 newtons because it's a Newton's third law of pair. So minus 100 plus mg, so that's the mass, which is 5. G equals 0. So if you do all this out, Ft1 minus 150 equals 0. The force of tension 1 is 150 newtons. So the force of tension here in this cable is 150 newtons. Okay? So you'll get to work on some worksheets now and try some more complicated problems than we've had before.